Okay. All right, so there's only 3 problems today, so I'm optimistic that we'll be able to get through them. So here we go. All right, so number 1, we have this equation, x minus square root of xy is equal to 4, and we know that dy dt is equal to 3, right? We're working with related rates now. Okay, so that implicit differentiation thing that we did a few weeks ago is now going to become very important. All right, we want to find dx dt when x is equal to 8. Okay, so in order to figure out what this dx dt is, right, we need this dx dt and this dy dt to actually show up in this equation. So in order to do that, we need to differentiate with respect to t. Okay. All right, so what do we get here? We get dx dt minus, right, and then we're going to have a chain rule. Nope, things are happening in the chat. Okay, that doesn't concern me. All right. Now we're going to have this chain rule thing happen. Okay, so we take the derivative of the square root stuff. Okay, so imagine that that's a power rule. All right. And then derivative of the inside is a product rule. Okay. So just like when we did all that implicit differentiation. All right. And the derivative of the number 4 is 0. Okay. So now we have all of this dx dt, dy dt stuff running around. Okay. And we'll notice that in order to actually solve for dx dt and get a number, right, we have almost all the information we need. We know dy dt, we know x. What we don't know is y. Right. But we can figure that out because we have this equation here. Okay. Right, so when x is equal to 8, and then we're going to have 8 minus the square root of 8y is equal to 4, and solve for y. So let's see what happens here. We're going to get square root of 8y is equal to 4. So subtract and then move things over. And then square both sides and then divide. So 8y is equal to 16. So y is equal to 2. Okay. And it looks like I might need more room, but I think I can cheese it. There we go. Okay. So I know that x is equal to 8. dy dt is equal to 3. And y is equal to 2. So just shove all this information into this equation here. And what do we get? dx dt minus 1 over 2 times the square root of, let's see, 8 times 2 is 16. X is 8. dy dt is 3 plus y is 2. I don't know what dx dt is, and that all should be equal to 0. And then let me real quick here. Okay. All right. As always, right, stop me if you need to. Okay, so now we're just back in algebra world. So I'll say the words, but I'm not going to write down all the steps. And I'm going to distribute this thing to each piece, collect like terms. So collect the dx dt's, and then move all the numbers to the other side. Okay, so once the dust clears, and again, I'm not going to write down all of the details if you're interested. You're more than welcome to convince yourselves that this is true on your own. Okay. So when all this happens, we get 3/4 dx dt is equal to 3. So that's going to tell us that dx dt should be equal to 4. All right. Questions? Where to put dx dt and dy dt? Are we talking up here? So this came from chain rule. Right, so when I take the derivative ddt of the square root of xy, right, chain rule is going to happen. So the first thing that happens is the derivative of that square root. Okay, so that's the 1/2 times xy to the minus 1/2. Okay, that's the first thing that happens, so that's where this thing comes from. All right, and then chain rule kicks in and says we have to take derivative of the inside, so the derivative of this product, and then we have a product rule. So product rule says you take first one multiplied by the derivative of the second one, but the derivative of the second one involves a dt, so we have a dy dt. And then we take the second one and multiply it by the derivative of the first one, or vice versa. It's a sum, so it doesn't matter what order you do stuff in. But again, we took a derivative of x with respect to t, so we have to say dx dt. Right, so really this came from chain rule. Yes, that's exactly right. Yeah, you're welcome. All right, any other questions? All right, so the only time calculus happened in this entire problem was right here. This is the only place that calculus happened. Everything else was algebra. Okay. All right, so now we're doing related rates in a actual context, right? We have a real world problem now. All right, so we have this ladder and it's up against a wall and the bottom of the ladder is moving away, right? So you can imagine the ladder is sliding down the wall. Right, so the question is, when the bottom of the ladder is a meter away from the wall, how fast is the top of the ladder falling? Okay, so the first thing that we want to do, and the first thing that in your head you should be thinking you want to do, is draw a picture. Okay. So we've got, hopefully, oh good, alrighty. All right, so like there's my wall, and then I have a ladder. Let me see if I can get fancy here. There we go. The only thing about the online teaching that I'm going to miss is being able to draw a dashed line straight. Okay. Oh, that's not even a right triangle. Dang. Okay. There we are. All right. So here's my wall. And here's my ladder. And I know that the ladder is 3 meters long. Okay. All right. So this is the setup. So in order to actually do any kind of math on this thing, I need to introduce some variables here. All right. So I don't know how far the top of the ladder is from the ground, so we'll give that a name. I also don't know how far in general, the bottom of the ladder is from the wall. Okay? We have a specific instantaneous, like this is where it is in our problem, but in general, I don't. So this is the picture we have. Okay. Now, when I stare at this picture, I see a triangle, I see a right triangle, and whenever you see a right triangle, you should think Pythagorean theorem every single time. All right, so this is the equation that we want to work on. Right? I can't get, dx dt, dy dt, all this stuff unless I have an equation. So now I have an equation. Okay. So since we're in related rates world, we need all these dt's to show up, so we'll differentiate with respect to t. All right. But I'm getting ahead of myself. Before we do that, let's actually write down what the problem is. Put all this stuff to good use here. So we want to find, all right, we want to figure out how fast the top of the ladder is falling. So what are we looking for? If I want to know how fast the top of the ladder is falling down, which quantity am I looking for? So y would be the distance that the top of the ladder is from the ground. But I'm looking for the speed that it's falling. So how do we represent that? dy dt. Perfect, right? That's what I'm trying to find. I'm trying to find dy dt. Because that represents how fast y is changing, so the height of the ladder above the ground with respect to time, right? That's what this fraction means. Change in y with respect to time. Okay, so I want to find dy dt given, and I know some things, given that the ladder is supposed to be 1 meter from the wall. So that means x is equal to 1. And I know that the bottom of the ladder is moving away from the wall at 0.1 meters per second. Okay, so that means dx dt, the rate at which the foot of the ladder is moving, is 0.1. Okay, so this is the setup. This is the problem. I want to find dy dt given that x is 1 and dx dt is 0.1. All right, so now I can differentiate. And we're in business. Okay, so we've got a couple of power rules. So we'll have 2x, but since I took the derivative of x with respect to t, that dx dt shows up. And same for the y. I get a 2y from the power rule, but I took a derivative of y with respect to t, so a dy dt shows up. Okay, just like in the problem before, there's one more piece of information I need. I need to know what y is, but I know what x is, so I can use the Pythagorean theorem to compute. So when x equals 1, we got 1 squared plus y squared is equal to 9. And this one, I'm really not going to show the details because it's not super complicated. All right, y is the square root of 8. Okay, so now I have all my information, so I can just plug it in. So x is equal to 1, dx dt, and I don't like decimals, so I'm going to write 0.1 as 1/10. And y is the square root of 8. So we get 2 times 1 times 1/10 plus 2 times the square root of 8 times dy dt is equal to 0. And when all is said and done, we're going to have, let's see here, dy dt is going to be negative 1 over 10 times the square root of 8. Okay. Questions? All right. So the hard part here was just setting up the problem. Okay. Once we had the problem set up, we were in business with just doing our standard related rate stuff. Differentiate with respect to t, figure out all the quantities that you can find, decide which one you need, and then find it. Right? And the one thing that we can say, right, to help check your answer is that this minus sign makes sense. Okay, because the ladder is falling down. All right, so there's a little physics thing, right? We can introduce direction to everything and say that down means negative. Okay, so x is moving in the positive direction, right? Just imagine you just put an axis on this thing. X moves in the positive direction, y is moving in the negative direction, so I should get a minus sign here, and we do. Okay. All right. Okay, now we're sketching graphs. Okay, this is the last problem. Graph sketching. So this first one, we have all these different tools from algebra that we have to sketch graphs, right? Looking at the roots and all of that stuff. Okay, so this first one isn't going to be too challenging. All right, for part B, we'll have to use some calculus, figure out where our asymptotes are, find what direction, where the increasing, decreasing stuff goes. But this one, not too bad. So this function here, let's just write down things that we know. Right? It's a cubic function, first off, right? If I multiply this whole thing out, I'm going to get an x cubed. The leading coefficient is negative, right? It's actually -1, but negative is good enough. Okay, so if we remember our algebra, you know that the shape is going to be something like this. I don't know exactly what's going on in the middle yet, but I know that it's going to be increasing going to the left and decreasing going to the right. Okay. And then I know what the roots are. Okay, the roots are 0 and -1 with a multiplicity of 2 at -1. Okay. So again, if we remember our algebra, multiplicity 1 means that the graph crosses the x-axis at that point, and a multiplicity 2 means that the graph touches the x-axis at that point. Okay. Okay, let's put all this together and I can get a nice sketch of my graph. Come on, there we go. Okay, so I know it's got a root at -1 and I know it's got a root at 0. So when I go to actually plot this thing, and I know it's going to come down this way, okay, touch right there, go up, 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 and I know it's going to cross right here. All right, the one thing that I don't know from all my algebra is what this hump looks like. Where is the top of the mountain? That's where calculus is going to come in. So that's going to be where that critical point is. Okay, so that's where the calculus comes into play. Right, so I will put right here. Whoops. Okay, so I need to do some calculus. Okay, so let's take a derivative. All right, so there's a product rule here, right? So take the derivative, I'm going to get, let's see here, -1 multiplied by x plus 1 squared. And then a minus x multiplied by 2 times x plus 1. Okay. Product rule. All right, so what is this thing really? Well, it is what it is. I won't simplify it. I don't care. Okay, but now I have to set it equal to 0 and find the critical point. Okay, so 0 should be minus x plus 1 squared plus, actually minus again, 2x times x plus 1. All right, I can do a little bit of sneaky stuff here. Factor out an x plus 1. Those two minus signs can go away. I just divide by a minus 1. And then what do I have left? Is an x plus 1 minus, or actually plus a 2x. All right, do some algebra. Zero product property tells me that x should be either minus 1 or minus 1/3. I already have my minus 1 on my graph. I knew that from before, right, because it was a root. But now I know exactly where the top of the hump is going to be. Top of the mountain is going to be at x equals minus 1/3. Okay, so now I can actually get a good sketch. Maybe. All right, so I know about minus 1. Now I know about minus 1/3. And I know about 0. So my graph is going to look something like, let's see, comes down, touch, top of the hump is there, and then crosses through. Something like that. Okay, questions? All right, so from our algebra stuff, there's a lot of things we can do to get a good read on what a function does. Okay, but it doesn't give us everything. It gives us, pretty much it just gives us shape, right? But we can get nice specifics when we use calculus, like figuring out where exactly the top of that mountain is, where that relative max is. Okay. Last one. We want to sketch the graph of this function. X over x plus 1 squared. Okay. So now that I have this rational function, the first thing I should be thinking about is asymptotes. And the one asymptote that jumps out immediately is that vertical asymptote at x equals -1. Right. And if I take a limit as x goes to infinity, I see that we have a larger power in the bottom than we do in the top. So that thing's going to go to 0. So that tells us that f has a horizontal asymptote at y equals 0. Do things just by looking at the function. Okay, now I need to figure out increasing, decreasing, relative min, relative max, all that good stuff. So I need to take a derivative. All right, this is a quotient rule. So here we go. Quotient rule says we take the derivative of the first multiplied by the, or derivative of the numerator multiplied by the denominator. Our derivative of x is just 1, so we just have x plus 1 squared. And then numerator multiplied by derivative of the denominator. All over that denominator squared. Okay. Now, since we actually have to solve for things, we need to set this thing equal to 0. All right, we need to actually simplify this thing. Okay. But that's really not too bad. Try to keep this on one page. So there's an x plus 1 all over the place. So I can divide by it. Okay. And then combine like terms in the numerator. Get 1 minus x over x plus 1 cubed. All right. So now we've taken a derivative. Okay, so now I need to figure out increasing, decreasing. So I need to know what my critical numbers or undefined spots are. So not too hard to see here that we're going to have an undefined spot at -1 and a 0 at x equals 1. Okay, so if I make my number line, I'm going to have, whoops, -1's going to be here, 1's going to be there. Right, but I know that I have my vertical asymptote at -1, so it's not going to be an actual critical point, but it's still something I need to consider. And then I need to use test points to figure out what f prime is doing. Okay, so this is something we should be familiar with now. So if I plug in something very negative, okay, this denominator is going to be negative, right? I take something negative and I cube it, it's still negative. But in the numerator, I'm going to have something positive because I'm taking 1 and subtracting a negative, which is the same as adding something. So altogether, this is going to be negative. All right. In between -1 and 1, so like 0, okay, we're going to have positive divided by positive. Why is it doing this? I thought I fixed this problem. And then if I pick something very positive, I'm going to have positive in the denominator, negative in the numerator. So f prime is going to be negative. Okay. So this tells me information. All right, let me pause here and ask if there are any questions. Before we draw the picture. Okay. Now we can use this information and actually draw a picture. So let's see. Oh, we also see from here, all right, we change from increasing to decreasing. So we're going to have a relative maximum at x equals 1. Okay, so I've got a vertical asymptote at -1. All right. From the definition of the function, I know that f of 0 is 0, so I know I'm going to cross right here. And then I know I have a relative maximum at 1, and if I actually compute what that is, it's 1/4. So I actually know kind of how high that goes. Again, we're sketching, so it doesn't have to be perfect. And then I know I have a horizontal asymptote at y equals 0. Okay, so at the ends, right, my function or the graph shouldn't touch the x-axis. Okay, so let's put all this information on here. Whoops. Okay. So when I draw my picture, I know that I'm decreasing from -infinity to -1. So my picture is going to look something like this. And then I'm increasing from -1 to 1. Excuse me. Okay. Increasing from -1 to 1. And I know that I'm going to have to, at some point, cross through 0. And we get right here at that relative maximum. And then I'm decreasing from there. But I also know that I have a horizontal asymptote. So my graph of my function looks something like this. Okay. Questions? All right. So that's the last one. That's all the problems for today. So we finished early for the first time. That's cool.